Now, after a nice recap for the previous chapters, let me give you some introduction part. Now, you must be also confusing that when a sine function is not 1, 1, then how we can find the inverse of the function. Okay, so we can, lot of things are there which we can do it. Now, first of all, how we are writing the inverse. Okay, normally we are writing f inverse x. Okay, we are using this word for the inverse. Now, what exactly in this chapter we are going to do is, we are going to study about the restrictions on domain and ranges. Remember one word, restrictions. I just gave you a Venn diagram with lot of values, even I can say infinite values were there. Okay, so we can draw a Venn diagram for that part. But what about if we are going to just alter it for finding the inverse? Domain becomes range and range becomes domains, then what to do? Okay, so now we are having in this chapter restrictions on domain and range of trigonometric functions which ensure the existence of their inverse, and observe their behaviors through graphical representation. Okay, when we are going to do the graphical representation, then you will see that how nicely each and everything is cleared in you. Okay, I will make my best to represent this chapter in a very nice manner. Okay, so now an English mathematician, Sir John, normally it is called Sir John Herschel. Okay, I am going to write his full name. It was Sir John Frederick William Herschel. Okay, so it is Sir John Frederick William Herschel who gave for some restrictions. If we are doing some restrictions on the domain and range, then we can find the inverse of the functions. So this was the first English mathematician and he was having a lot of qualities. He was a polymath, mathematician, astronomer, chemist, inventor and experimental photographer, or lot of qualities he was having. Okay, so he gave the notation for writing sine inverse x like this, cos inverse x, tan inverse x, like this. These were the notations given by Sir John Herschel. Okay, now what about this sine inverse x? Okay, I am telling you that these are the notations we are going to use it. You are saying okay sir, no problem, we can, but this convention logically conflicts with common semantic for exponential or the expressions like it is written now. Suppose example, we are writing sine square x. Now what to do it for sine square x? Okay, it's all right. Now it in algebraically and the composition part, basically there was some lot of difference. Where it was, if we are writing multiplicative inverse, now you have already done multiplicative inverse. If we are writing 4, what is the multiplicative inverse for 4? You will be writing 1 by 4, means 1 upon that reciprocal, that was the multiplicative inverse. Okay, and something with the composition functions. For example, what we did in the first chapter, one function was a function from, suppose it is from a to b, a function f from a to b. Second is, suppose a function is g, a function g from a to b. So can we find the inverse of that functions also? So basically there was some confusion. So later on mathematicians, what they gave, they just clarified the things. Now where some confusion was, let me tell you. Suppose we are having sine square x. Now to sine square x, can we write it sine x whole square? We can write it, but we are not going to square the angle. Okay, we can, this is one and the same thing. Now let's move for the notation given by Sir John Herschel. We are having sine inverse x. Now can we write it sine x like this? No, this is wrong, because what this becomes, this further becomes 1 by sine x, and 1 by sine x is not this part. 1 by sine x and this x, they are not equal. 1 by sine x is not equal to sine inverse x. Remember this thing. Okay, it is not equal to sine inverse x. Now what is then sine inverse x? We are going to clarify. Then how other mathematicians, what they did? Other mathematicians, they gave a new term for this one. Okay, they gave a new term, and the new term was arc sine x. Okay, this means what? This means sine inverse. So nowadays you will find these things are written on in the book. Why? Because due to some confusion between multiplicative inverse and compositional inverse. Okay, so now we are going to start with a nice thing about the chapter, and that is basic concepts. And before that, let me tell you, sometimes occasionally inverse functions are called cyclometric functions. Okay, they are normally, sometimes, occasionally they are called cyclometric functions. Okay, we are not using it. Sometimes they are called cyclometric functions. Okay, now we are going to start with the nice basic concepts with all these things: sine inverse x, cos inverse x, tan inverse x, and all these things.